Hello, everyone. Thanks for coming. Oh, yeah, you can really not see anyone. I actually wanted to ask some questions. We are in the Geek Out track, so who here identifies as a geek? Okay. So this talk is going to be about game development. Is anyone else here in the games industry? Anyone working in games? Well, that's not many. So, yeah. Oh, wow. I'm Stephan Dilly. I founded Game Roasters in 2019 and sold it in 22, a company that was basically using Rust in any of their game products. I'm an open source maintainer of Git UI and LifeAsk, also completely written in Rust. I founded Rust Unit this year to completely focus on Rust specialized consulting across the sectors. It's not just game development, but we are engaging in the Bevy ecosystem. What is Bevy? We will talk about that a little bit later. We are hosting the virtual Bevy meetups for that. And the talk today is going to have a few goals. Why did we choose to use Rust in games? How did the usage of Rust change over time? Some of the war stories, obviously. And where are we today? So it started all in 2019 when we wanted to build a game that needed to have shared game logic between server and client. So, and a very intensive, compute-intensive AI calculation. So back in the days, I would have used C for that. But it was time. Rust was stable. 1.0 was already a few years old. And we wanted to have no garbage collection. We didn't want to touch C again. So, and obviously, we drank the Kool-Aid. Hey, if Rust builds, then it works. And the long, vision of, or more like a dream of eventually maybe able to build a full-stack mobile game in one language, and that being Rust. So the first few steps that we took were still pretty simple. We used a shared library written in Rust from the Unity side in the front end and from the Go-backend that we still had at the time. So it was sharing this code written in Rust via the old-school ways of a C interface. That obviously had a lot of complications. At least it tackled the problems that we wanted to solve. It was fast, and it was covering the AI calculations that we wanted to do. But it was hard to maintain. We still had to talk via CFFI and to transport complex data structures between. We used string JSON APIs essentially. The next problem was we had to maintain 3 languages with Go, C#, and Rust. The problem didn't end there. We had to parse complex JSON from C#, which was super slow in mobile games in Unity. And that all made it a little bit clunky, but at least the AI problem that we had was solved. Then fast forward to the end of 2019, there was a huge moment in the Rust ecosystem being stabilized, async await. Essentially, you can imagine, okay, it allowed to do the ergonomic way of event-driven I/O that we are all used to from JavaScript and all the other languages. And then everything started to super accelerate. There were official drivers for MongoDB. We got client requests to build backends in Rust. And we actually thought, what could go wrong, right? Let's build a game. Let's build a backend for a client in Rust. So we needed to use this MongoDB official driver, and it turned out to have a very crucial connection pool handling bug, which we had to fix in production, essentially, because the server was just basically locking up every 1,000 users or something. And that was a quite sobering experience to use this sort of emerging technology at the time. But we were still very convinced with the outcome of high performance and stability once we made it stable. And so we chose to use this full-stack Rust backend now for our first own game product, which was called Wheelie Royale. There should be a little trailer now with sound, which is not here. Okay, well, imagine an awesome soundtrack. I have no idea.
Is it going out via the clicker? Yeah, there's sound.
So it should be there, huh? One last try. Okay, I don't know. Anyway, the backend for this was still very simple. We had to store these replays, make sure that there's no like cheating going on, and that you can really rely on your high score there. But more on that later. So in the next iteration, we wanted to improve on that concept. We were still not, it was still not time to move away from Unity and established front-end engines. So we still were stuck with that. But we at least wanted to improve the ergonomics that we were using there. So going away from JSON, going away from stringified APIs, we wanted to use protobuf instead, have code generation for our now fully written in Rust backend and for our C# frontend. So at least there's no error-prone like manual data structure building anymore. And it was like blazingly fast compared to what we did with JSON parsing before. There were no GC hiccups anymore because what we're going to see on the next slide, we basically just reused the same data, the same buffer to write towards our Rust library and to read back from it to know what the response was. And so we were able to share more and more logic with the backend that was fully written in Rust. So yeah, you can see here the API basically shrunk down to this one logic call, and then you can imagine all kinds of different logics or different functions implemented based on a long list of enums inside this protobuf object. So the first time that this entire new approach to communicate between C# and Rust was implemented, was put to the test, was in this project called Tower Rangers. Imagine like a combination of idle tower defense game and real-time PvP. Oh. Well, this one works. Yeah. So that one was pretty successful from a technical perspective for us. But as you can see here, we had to build a lot of components for the backend to really cover what all the standard requirements are essentially for a mobile game backend. So we had to build authentication, single sign-on, Facebook, single sign-on with sign-in with Apple, Google. Very crucially, in-app purchase validation, push notifications, the real-time component that we were looking to have for this game and also for future projects was supposed to use some sort of pub/sub real-time multiplayer component. We had done A/B testing because there was a lot of overlap between our own projects here and what we needed to build for our clients, and friends list, leaderboards, and the standard tracking stuff. All of this is open source on GitHub. Like I said, the company is sold. This stuff is not maintained anymore. But as we can see later on, like what we are now using at Rust Unit is recycling a lot of that code because it was pretty like generic and not really tied to any of the frameworks that we were using at the time. So what was built on top of this solution was Stack 4. So Stack 4 was the first project that really made use of these real-time components and had an even more increased game logic implemented in the Rust core library and shared that entirely with the full Rust backend implementation. And there's also going to be a video. Brace your ears. Oh, this one has no sound again. Cool. Anyway, this is like a 3D version of the famous Connect 4 game. You have to make 4 in a row, but with the twist that it can be around the corner, as you can see here. It's against real players, against people in competing for the best ranks, obviously, and unlocking all these amazing cubes that you can see here. So yeah, all of this had one crucial aspect to it, which was that it was still using Unity in the front end. We were still using this very established old school engine. And yeah, that was not really relevant for a while because we were focusing on different areas. Game Roasters was sold. And then basically fast forward to last year, we decided to pick that topic up again and see where's Rust these days now when it comes to being actually able to write the whole game in it, like the full stack experience. And so we started using Bevy, which is sort of the biggest Rust engine out there. I'm disclaiming this obviously as this is not, if you expect something like Unity, this is not there yet. There's not even an editor. This is basically a great engine if you are coming from the development side and if you're willing to build a lot of tooling around it yourself. But it has also a lot of upsides. It is totally ECS driven. Hands up, who knows what ECSs are? What's the entity component system model? Okay, it's basically data-oriented design applied to games. That's the very short explanation to that. What this means for Bevy specifically is that based on this architecture, it can implicitly multi-thread your entire code and make sure that you have no problems with your data being accessed in like invalid, like insecure ways. That makes it obviously super fast. It is completely modularly built, which also means that the way you build your game on top of it is the exact same way how you would extend the engine inside, or if you want to look into the engine, how it works, it is exactly the same architecture. It is covering most of the platforms that we care about, specifically iOS, Android, and the web. And it's nicely compared to Unity, completely free and open source. So there's not going to be any platform fee, or then again, no platform fee. So you can totally trust this shit. And it's an enormous community. If you join their ways to communicate with the developers, it is like almost 20,000 people. You always get help. It is very like nice vibe. You will never be like booed for a dumb question, none like that. And yeah, obviously we had to build a lot of stuff from scratch. There was not, most of the things that you're used to using on mobile games was not there because no one in the indie game development community really cares for mobile games. So we had to start really from the beginning and implement a lot of the standard things, even for just building an iOS mobile game, like how to make the phone vibrate, how to ask the user for a review, how to open native alerts, how to push notifications to the device, and so on. So we started building all of that, and we were lucky enough to be able to do that on the open source side, so that basically everyone afterwards that wants to go the same route can just benefit from that and use these components. And all of this, again, open source on GitHub. So the first project that we built as a showcase on this is called Zoolitaire. It's very simply based on the solitaire game concept. You jump with your piece over the next, or over one next to it, and you can remove that one. Goal is to just end up with one piece. There's a little video of that, totally no trailer quality this time. So I think it's fine that there's no sound. Oh, there's actually sound. Yeah. This is 100 levels. This is on the App Store for iOS. If you want to check it out, you can play. Very simple, but showing off essentially the capabilities of integrating everything that you're used to on a mobile platform into a game built in Rust and Bevy. Like the rating dialogue. So yeah, there's multiple mechanics like we saw here. Animals like the panda can stack on top of each other. So a little bit about the backend stack this time, because the last time around, lots of things have changed in like what's the standard solutions in Rust, in the Rust ecosystem to use for building servers on top. And this is where I want to tie back to what I said earlier. We were able to reuse a lot of the components that we built at Game Roasters called Atlas. And this time around, it was just bundled together with a different server-side framework, which essentially, when you come from any other technology, dependency injection is not something super cool. But if you look at a very statically typed language like Rust, it's actually pretty exciting to have the same capabilities in there and build a modular type of backend on top of this. And so, yeah, this is what we are using here now. And the big advantage, obviously, now is some of the tough challenges that we had with validating the earlier game, Wheelie Royale, on the server side to make sure there's no cheating going on, became basically like a total no-brainer now, because it was completely everything the same code base. The same code that we run in Bevy is running on the server side, basically replaying what's happening and validating that there's no cheating going on. And so the project that is showcasing this now best is called TinyTakeoff. It's like a little Flappy Bird racing sort of style game that is multiplayer in the sense that you compete against other players. And it uses this deterministic game logic that's going to be run on the server side to validate what you played and showing other players your replays. So it has a bit of stuff in common with Wheelie Royale. And yeah, I'm encouraging everyone to scan this QR code and start playing against my high score now, because this is totally running on the web. You can just use your browser. You don't have to download anything. And I have a few Bevy stickers, you know, if you're interested in hearing more about Bevy. I didn't have a lot of time to really go into that in depth, but I'm going to be around afterwards for geeking out about more Rust and the Bevy engine. So hit me up and show me your high score on your phone, and then you get some Bevy stickers if you manage to make it to the top 5 slots or something. But obviously, I also want to show this quickly so that whoever doesn't want to load this up can also have a glimpse. This is not super huge, but whatever. Let's see. Yeah, I'm currently #1, so try to reach more than 78 points, then you're going to get a sticker. Yeah, obviously, flying wolves are eating sheep, so that's what we're going to have to avoid here. And collect stars. So the stars are for the ranking. And I'm not going to make it too far this time, I feel like. But I'm excited to see your high scores later after the talk. So yeah, for us, the decision to use Rust for games and for anything actually turned out pretty valuable because it makes game development a lot easier compared to what I was used to in the past. It's still far away from the all-inclusive engine that we are used to, but it's getting there, and it has a huge potential when it comes to the code quality that you produce and the ergonomics in being able to actually have the same skill necessary for front-end and back-end development. So yeah, that was my talk. Thank you very much for the attention and the excitement, hopefully now for Rust and Bevy and game development in it. We are offering services for Rust in any sort of area, so check out our website, and obviously don't forget to play and hit the high score. Thank you.
That was really cool. I honestly have so many questions, but that's good. You know, that's why, because there's no one else. I try to trigger the people into asking questions. But I have a lot of questions, actually.
I'm actually here.
Yeah, we have one from two. Go ahead.
First of all, thanks for the great talk. I'm really interested in the Bevy engine, and seeing as there's currently a huge overhaul of the UI system, I was wondering what you and your team were using to build your UI.
Yeah, that's one of the weak points, I would say, of the technology right now. The whole UI story is, as I said, there's no editor, and that usually makes building UIs very, very problematic. And what we use is the standard UI framework that comes with the engine. So it actually covers everything that you need. It actually basically implements CSS. If you're coming from the web, you pretty feel at home. But you have to basically start from you can put a text up, you can put a button up, and that's it, and images. So you can build everything on top of that, actually, surprisingly, but it is a lot of work. And I'm also very excited to see the development in the ecosystem there, to see more mature widgets, more stuff that's built on top of that, and obviously, hopefully, at some point, what you see is what you get editor.
Yeah, great, thanks for that answer.
Okay, before everyone leaves, I just realized I actually know a game that has been also written in Bevy and in Rust. Do you know TinyTakeoff from
Yeah,
Anna?
of course. Yeah, it's a huge project in the community. It's a little bit of a, you really want to make that on a slide and say, hey, this is Bevy, because it's actually just using the ECS component of the Bevy framework.
Okay.
Like I said, the whole thing is totally modular, so you can just pick out something. Mm-hmm. You can say, okay, I want my own renderer, but I want to use the ECS.
Okay.
Because that is really mature and strong, and that's what they did. They basically said, okay, I pick out what I want from Bevy, but we want to build our own renderer. This guy is like an insane rendering engineer from his previous jobs in the games industry, so he just built that stuff himself, but he built it on top of some of those components from
I think
Bevy.
it's two people, right? Like Anna, and I don't know the guy, but I played it. Oh my god, that's so cool!
It's really cool.
If you wanna go out and play or look at a really cool game, I think it's not yet out and it's on wishlist or something.
In October, it's pretty close. And they have a demo on Steam again.
Yeah, TinyTakeoff. Wow. Super cool. Like as a programmer, the whole time you're like, how the fuck does that work?
Yeah.
I have more questions.
They have a cute sheep too.
Yeah. It's also like honestly, TinyTakeoff is super cool. We have only a few more minutes but Melanie's not there yet either. Anyway, so we have a bit more.
She's waving. Someone's waving.
There. Okay, sorry, Melanie, I didn't see you. Okay. So you just said that like Bevy is a bit in the early stages of development still. Like there's not that much. Like there's no what you see is what you get. There's no, I don't know, rendering engine per default. 2D rendering, or there's a 3D.
There's everything. Like
okay.
The 3D rendering is actually also pretty mature, but that's more on the lack of art skill on my side or on our team side that it is not shown off in the games yet.
Ah, okay. And they used their own renderer because it's all procedural and that's different, maybe?
I think it's in a sense pretty out of the norm because it's already building on web GPU. So it's sort of like, hey, what Unity hopefully next year will support is going to be the default for this system. They obviously have some rendering path also for old school rendering on WebGL, what we are seeing in TinyTakeoff. But it's actually a super mature, progressive rendering technology already.
You think that's going to be a good competition for Unity and Unreal at some point, or is it just too much out there?
I think in terms of the capabilities, absolutely. In terms of developer experience, totally. But in terms of the usability for a whole team, when you're catering for artists and game designers, then no, because of the lack of an editor, which is hopefully in 12 months. But that's really the biggest crucial point right now. You have to build a lot of tooling around it yourself, or be willing to travel back in time 20 years and edit configuration files again to change where an image is and whatever.
Yeah. But I think like I will check it out. I honestly just did some embedded Rust so far, but like I don't know, still a bit afraid, honestly. But it's I think the
I talk a lot in my meetup with people that come to Rust because they found Bevy first. And it's actually surprising what kind of a easy entry into Rust this engine specifically does, because it protects you from this whole borrowing and lifetime issues that usually come as a very daunting thing with Rust.
Yeah.
Because it's hiding that all the way through the ECS, because you're not really using pointers, references, or whatever, because you reference everything by indices there.
Yeah. Yeah. I think that's embedded Rust is just don't start with embedded Rust. Okay. I have one last question. There's nothing else, so I get all the questions. Except for one. Did you have any problems with Rust while implementing, like when you get started? I mean, the obvious one is a lot of immature libraries, a lot of stuff that you have to fix, build yourself. But I put that aside, like stuff where you actually were like, this was better in Go, this was better in C, this was better in C++ or Sharp or whatever.
Honestly, no. I think the learning curve is probably the real thing that you have to just sit down and learn for a month until you can really start being productive with it. But now that I see Bevy, it might make that learning curve actually different, because I didn't start with Bevy when I learned Rust. But in terms of what the language really, in my opinion, doesn't have that I saw in other languages, I would say the only real big one is runtime reflection, or any type of reflection, so that you can more easily build meta-programming stuff on top of your code base.
Maybe you can explain runtime reflection really quickly?
Yeah, like being able to inspect what a certain instances type is, and then building functionality on top of that. A simple use case would be when we think of an editor, you want to be able to click on an entity, and the editor somehow has to know about all these types, their attributes, and show you a UI for that, and be able to let you manipulate that data, right? And so that is usually done on some type of reflection, whether that's runtime or compile time. But that's really probably one of the biggest challenges that Bevy is fighting right now, to get that working.
Okay. That's honestly still super cool. I hope we convince some people to go into Bevy.
It's growing more and more. I mean, it's making us work already for 6 years with Rust.
We'll try to get someone from the Bevy team or Anne.
That would be awesome.